Hey guys, welcome back. So last time we were talking about our initial setup for our crypto challenge. Also, Matthew and Cassidy gave us a brief introduction to what AI is. So if you haven't seen those videos, I'll put them up here somewhere, and you can just go back and watch those. But today we are going to be talking about the approach that Matthew and Cassidy took to the build phase. So first we had to do a bit of a setup for it. So guys, if you want to just walk us through that approach that you took.
Yeah, sure. So, I mean, the first decision we really had to make is what are we going to program this in terms of a programming language, and then what sort of environment are we going to use that we can sort of do our coding in and collaborate as a team to sort of achieve this goal of sort of a predictive model for Bitcoin prices. So yeah.
Yeah, so there's things like GitHub, and we used GitHub and a Jupyter notebook, which is a collaborative kind of programming platform. And because I had no Python experience going into this, kind of being able to watch him build it as he did it and follow along from there, that is how we accomplished it.
Yeah. So obviously, as I say, we use Jupyter Notebook, which is sort of a browser environment that you can create sort of blocks of code that you can annotate, and you can explain what you're doing as you go along, and also to do a lot of the sort of heavy lifting of the code that we need to do to get this model, to get this predictive model. We need to use a lot of packages and libraries within Python that are just sort of chunks of sort of functions and tools that somebody else has already programmed that we can plug in, and we can just get straight down to doing some analysis on the data we've got.
So as someone who's not really done a lot of Python development, how did you find that sort of collaborative environment?
I found it very helpful. So in the beginning, there was about a week or so that we had not set up the whole collaborative environment, and was feeling a little lost. But once we got the whole collaborative aspect down, and I can kind of see what he's doing as he did it while he's explaining it. Like we said, you can, in Jupyter Notebooks, you can leave comments and explanations to all of it. So I was able to follow along with that, while also teaching myself Python on the side using Code Academy, which it's free for everyone, free to learn, and it really helped. By the end of this, I was feeling pretty confident with Python.
Yeah, exactly. So there's loads of different things out there to help with learning Python, but again, your point about annotating things. So one of the things that we find is, as long as we annotate it, that way when someone else comes along and starts developing, so if you're in a workplace, someone's going to leave. If you come to someone else's work and it's not been annotated,
Very hard to follow.
Yeah, it's virtually impossible. Trying to break that down it's hard. So those annotating points help not only with building it in the first place, because you're sort of explaining it to yourself, and then explaining it to someone else when they come to it next.
Definitely. Exactly. I mean, at the end of the day, it is a programming language, but it is a language at the end of the day. And I and every individual has sort of a code in handwriting, and if you haven't made your work as open and annotated it to let other people know, then something that may be obvious to you is alien to somebody that hasn't seen that before.
Yeah. So if he had just sent me blocks of code in an email or whatever, I would have been terrified and very lost.
And that's the thing, it makes people scared of this whole world. I mean, the whole data and AI world is quite scary for a lot of people, and not knowing where to start is the biggest challenge. So for us, we want to make sure it's as accessible to everyone. So it's why we've got the channel. It's why we want to make everything as jargon free. And in some ways, we want to call out some of the people who try and make themselves sound a bit more important than they actually are. But I mean, we did a lot of setup, so we prepared ourselves quite well, I think, for the essentially the next step, which was the model building. You know, the crucial step for all of this. We've prepared everything. We've got all of our data in the right frame, sort of processed in the right way, so that we can start building it. So I think if we talk a bit more about that.
Yeah, so as you say, the first stage of any sort of project is once you know what you're trying to do, you need to understand what data is available. We obviously used data that we took from the Crypto Compare API. We got a load of different columns of historical price data for Bitcoin, and it's all about just taking that data, putting it in a format that is readable and clear, making sure that it isn't messy, there isn't any missing values or anything that shouldn't be there, anything anomalous, and then it's all about putting it in a format that we can apply some sort of predictive tool to get some analysis out of it.
Yeah. I think we were a bit more careful as well with the data that we were sort of making sure things were there. So because if you start messing with the data a bit too much, you can then add, say, a bias to it. So because you as a person are aware of something, you will change those items that you're most aware of and not the ones that you're not really aware of. And so if you do that, then obviously the model's going to see that and it's going to get that same bias within the model.
Definitely. I mean, biases like algorithmic bias is something you have to consider in any sort of AI project. And really, what you're trying to do is do the least amount of editing to your data set that allows it to be coherent and readable, so you can actually get some action out of it without, as Rohit says, essentially just changing your data so much because of what you want to get out of it, that inevitably that's what you end up finding, because that's all you've allowed it to look for.
Exactly, which is also going to be a lot less accurate.
Mm.
Yeah, and that's the thing. You can technically make your data say whatever you want, but that's not going to help you in the business context or in this aspect either.
A little.
Yeah. So we've gone a bit around the model. So we've built the model. So let's talk about some of the next steps that we've had to take.
Mm. So yeah, in terms of sort of the predictive model that we built with this sort of data, obviously it's time series data. It's sequential, so that one point is related to the point surrounding it. So with Bitcoin, obviously the price of the previous day is relevant to the price of the day you're on, and relevant to the price of the day after that, and so on. So with the fact that all these data points are linked, we need a specific type of model that can help us deal with that. It needs to be what is called, I mean, it is jargon, but it's recurrent neural networks. It sounds scary, but really all it's doing is it's allowing us to create links from in time across our data, so we can show. It allows us to predict more accurately the price of anything in the future, because it's linked between multiple points in time. So it's looking at it's grouping it more together, so it can get a better idea of the trends.
Yeah, so it kind of learns from its own past data.
Mm-hmm.
Yeah, and that's the thing. So obviously it's not going to be just representative of what the past data was saying. There are other aspects. It's why we wanted to introduce the social media posting as sort of an additional aspect of why the prices go up and down. So in terms of the model, I mean, we've got it built initially. So once it's built, that's the final build. We have to go through a process of taking that model and then training it. So I mean, training it is, I guess we need to sort of explain a bit more about that.
So essentially our aim here is to try and get to teach some algorithm or model from past trends in Bitcoin price data, trying to learn some sort of trend so it can help us predict future Bitcoin prices. So what we need to do whenever we train sort of any sort of model or algorithm is we need to take all of our data and we need to split it up. We need to make it so we have data that we use for training and then data we use for testing. Because if we have, if we just trained our model on all the data we've got and then we come to test it on that data, it's already learned it. It's just showing us what it's taught itself.
So it's only fit to a specific few inputs.
It wouldn't actually be telling us anything, because
Exactly.
what we're trying to do is trying to show it a certain amount of data, so a certain amount of years of Bitcoin price data, and then we train it on that, and then we show it something it's never seen before, some current Bitcoin price data, and we see how well it performs in predicting those prices.
Yeah. So I mean, training it is probably one of the most important parts, and yeah, that aspect of splitting up the data, because otherwise it's you're never going to see whether it's so accurate, but as well whether it's going to throw out any anomalous readings for you as well. So we've trained it, but then the next step is sort of evaluating it. So, I mean, what was your guys' process for evaluating the model?
So for evaluating the model, so we actually split it into 3 different data sets. The testing data set, or the training data set, the testing data set, and then the evaluation data set. And similar to kind of the training, the model produces a visualization of it, and we can see just how accurate it is.
So whenever you sort of train a model, you can program it to throw you back sort of percentage errors. So how much something called loss or error rates, and it's just a sense of how off your model is, and it's all about evaluating how accurate or how much error you've got with the training data. So how successfully the model has learned the past trends, and then you can evaluate sort of the error with the test data that you show it. So and then you can compare those error rates, and you can see if you've got it's important to compare those error rates, because if you've got a very low error in your training data, your models learn the trends very well from that data, but it could still be terrible when it's applied to other data, and that's just a case of your model, you've overfit your model. It's only learned for that specific data and nothing else, and it's useless.
Yeah, so having an error rate of 0 might sound like that means your model's working perfectly, but like you said, that is overfitting. The 0% error rate is suspicious.
Yeah, always be wary if you're 100% right.
Exactly. So I mean, we've talked through the build approach that we've taken. Obviously, it's not something that's from a professional environment. Not really tailored to doing the agile approach or waterfall approach. But at the end of it, we've got essentially what we've wanted. But I think probably should just explain some of whether you guys came across any problems throughout this process that you had to fix, and sort of how you fixed them.
Yeah, I mean,
we definitely encountered some problems.
Yes, I mean, in every project, any time you pick up coding, there's going to be errors, there's going to be problems, and sometimes it's like beating your head against a wall, and you're happy when it works, but really it's all about working it through. And I think the main problem you can have is trying to go too complicated, trying to do too many things. So when you code in a model or an algorithm, it may be tempted to just chuck everything at it and lots of layers, and it be super complicated. But oftentimes that just makes your model worse and makes your predictions worse. So it's really about finding that sort of sweet spot of complexity where it's complex enough to get some insightful analysis out, but not overly complex, where you're getting into the range of overfitting or underfitting and really getting nothing useful out of it.
Okay, yeah, and sort of after all of that, how do you guys think it went? Sort of, would you change any of your approach to it?
I don't think so. I think we definitely achieved what we were aiming to accomplish. There were some hiccups along the way with coding and whatnot, as there always is, but overall we definitely achieved what we were trying to, and because of that it is more reusable. So we kind of mentioned this briefly in the last video, but now with this same model that we've built, we could use any other coin in any currency.
Yeah, I mean, there's always more you can do. That's the danger with this sort of area, with programming in general. You can always add more. You can always make it more complicated. There's always more you can do. But at the end of the day, I think we did achieve what we set out to achieve. In the future, obviously, that's the exciting thing with programming. You can take things further if you want to. But
you could build off of it, and
exactly.
We could use the Lunar Crush API. Add that to this like we were planning on doing. You can, it's very easy to build off of.
Exactly, and that's the thing. It's like we start simple. You don't want to overcomplicate it, because if you start doing that, you'll get lost. Whereas we've done something very simple in the first aspect. So yeah, in the future we can take this and then build on it further. So I think we've done quite well out of this 3-week build phase.
Yeah, so even a project as small and simple as this, that 2 students could do, one with no Python experience initially, smaller businesses and any businesses can build things like this and then build off of them and do all sorts of crazy stuff with their data.
Exactly. So that's it. Thank you guys for watching. In the next episode, we're going to go through the results of what we found, and do like a proper review on how everything went, and our approach, and a few more things on what we do differently. But thank you for watching, and please stay tuned for the next episode. So see you guys.